Welcome to qnawire.
All right, so we're starting with benzoic acid. We're going to react it with ethyl chloride and aluminum chloride. And the question is, what is the products, if any? And then additionally, we may like to know where if we add a substituent, where it's going to end up. So the first thing we need to consider is will the reaction go forward with the carboxylic acid group on the benzene? Well, carboxylic acids are withdrawing groups, and therefore they are somewhat deactivating. And this is through resonance. So we can draw a resonance form for this real quick. And it's not too hard to see how this resonance is going to affect the ring. This double bond can move up here. And we could continue this resonance to show that there could be a positive charge here and a positive charge here. That is to say that the carboxylic acid, resonance puts a positive charge throughout the ring, which is deactivating because we need these double bonds to act as nucleophiles. And that specifically, these positions, which I'll highlight here, ortho and para, are partially positive and therefore not strongly nucleophilic, and are the positions that are going to be deactivated, meaning this is going to be a meta-directing substituent, the carboxylic acid. So it's not so strongly deactivating that no reaction will happen. It's just that if a reaction happens, it's going to be adding this functional group at the meta position. Okay, so now let's just kind of step through what this reactant will actually be reacting with, or what our benzene will actually be reacting with once our ethyl chlorine is activated by the aluminum chloride. Recall that that's going to look like this. A lone pair on the chlorine attacks the aluminum and creates the following electrophile. Right. And it may not actually be exactly like this, where we have this isolated anion or cation floating around in solution, but that's practically what will happen. Okay. So we just need to attach this to a meta position on the ring. That's pretty much all there is to it. Don't think it's totally necessary to step through the mechanism for EAS, given that it's the same for pretty much every reaction. So that would be our product. It's also possible, so now we know that this is an activating group, right? Methyls donate alkyl groups donate electron density. So we could run into the problem of over-alkylation. Right? This is why typically we don't do Friedel-Crafts alkylation, but instead acylation, where we add, if we wanted to add an ethyl, we would add this acid chloride and then later reduce it, right? So that the intermediate before we reduce it would be deactivating. So more likely than not, we'll end up with some of the mono-substituted product, but also some of the di-substituted product. So that would be the answer. There's really two products. There's the version that has a single ethyl group and a version that has two ethyl groups.